Hello, learners, and welcome to the next part of our brief journey into organic chemistry. Next up, learning more about why carbon is a superhero element and how carbon creates complex organic molecules. Meet CarbonMe. Here he is. Okay, a visual representation of what we know is true about carbon and organic compounds. We know carbon is the basis of our organic compound organic our organic chemistry definition, right? That organic compounds are made up of carbon and at least one carbon-hydrogen bond. So I kind of made them to have at least that carbon-hydrogen bond here, and then of course room for other bonds here. Okay, we also know that carbon can bond with other carbons, nonmetals, and halogens. They can form single, double, and triple covalent bonds, of course. And carbon can catenate and form rings, and of course, straight chains and branches. And all of these bonds are stable. And this is kind of like our mini intro into carbon. But why and how does it all happen? For this lecture, we want to go a bit further and review details about carbon's ability to bond to get all those full details in the end. Okay? So we start by asking questions like, why carbon? Why does carbon atom make 4 bonds? How are covalent carbon bonds created? How does carbon create so much diversity, right? How can I see like an organic chemist and be able to identify these carbon structures? And finally, can I get some practice with those structures? Okay? And then of course, as you go along in this lecture, there is like a little bonus lecture, a couple of minutes about carbon man in action. If you want to know what can he do, who can he save, right? Just all these little details that we'll get into in this lecture. So why carbon? Really, it's atomic properties and bonding behaviors. We'll talk about atomic properties first. Okay, so carbon, we know, can form up to 4 covalent bonds. And we know because we're talking about organic compounds, one of those bonds needs to be a carbon-hydrogen bond. Okay. Also, we know that carbon is in period 2 of the periodic table. So a couple things that's awesome about that. No low energy d orbitals that are randomly hanging around to be reactive, meaning no exceptions, right, to the octet rule. That's what we're talking about here. Anything that is in period 3 or below have open d orbitals that have the ability to react. Okay. We also know that carbon has 6 protons, of course, and 6 electrons when it's neutral, like we see here. So 6 protons, 6 electrons. We also know the atomic mass just from the periodic table itself, which is pretty cool. We also know that, yes, it's in period 2, but it's also in group 4A. So we also want to just kind of make sure that we're going back and being able to read the periodic table. Okay? Now, carbon's ground state electron configuration shows 4 valence electrons. That means this carbon, its goal is to be like these noble gases, right? We're thinking about the octet rule. So the carbon wants to either gain 4 electrons of neon or lose 4 electrons to become like helium. Either way, it just takes a lot of energy, very unfavorable. So in atoms, the goal is that they want to go to more stable type of reactions and have more stable reactions, right? Of course, unstable reactions happen, but we're talking about the periodic table here. We're talking about things that are neutral and stable at this point. So when you're thinking about carbon, you're like, okay, is it going to give up the energy to lose or gain electrons, or will it want to share electrons? Well, guess what? Carbon is going to want to share electrons. And when you're sharing electrons, you're creating covalent bonds, okay? And that's the reason why carbon likes to create covalent bonds. 1, it's just energetically unfavorable to do any other kind of bond. And 2, also we can go further and talk about electronegativity. Carbon has an electronegativity of 2.5. We're looking at the electronegativity of lithium or fluorine, for example. I automatically don't think of numbers. I specifically think of those electronegativity trends that we see on the periodic table, for example, right? So we know if we go across a period on the periodic table, you increase electronegativity. And if you go up a group, you also increase electronegativity. So with the lower electronegativity and the higher one, carbon's kind of right there in the middle, which even lends to the fact that it's going to want to share electrons, okay? And of course, we got to talk about the stability of carbon and why the bonds that it creates are stable. That's going to have us going back a little bit further to more detail. Before we get there, I definitely want to go back to the electron configuration here of carbon. We see that we have the noble gas helium. This is the shorthand version of this. And then, of course, we're showing our valence electrons. So we can write it as our 2s and then our 2, well, really, there's 3 p orbitals here. And there's only going to be our 2p. Let me go ahead and write 2. Boom, 2p. Of course, you can fill up these actual orbitals. So we have 2 in the s orbital and then 2 here. As you can see, automatically, there's room for an electron here, here, and then room for 2 there. So initially, when we were learning about how things bond, it's like, oh, well, there's 4 spots, so that's it. But as we go higher and higher, we start understanding, 1, the geometry of these atoms, and also 2, how covalent bonds, or at least theories of how covalent bonds actually form. Okay? And how do we do that? We use two theories. We use the separate theory, which is what we're going to start off with. And then for here, we're going to use valence bond theory. So the separate theory is valence shell electron pair repulsion. It's basically saying electrons are a negative charge, negatively charged, right? So when you get two negatively charged things together, they're going to repel. And so valence shell electron pair repulsion theory is saying that when you're creating a molecule, the electron pairs are going to be spatially arranged so far apart and perfectly aligned with the nucleus so it actually can form a covalent bond, right, and share the electrons, but they're going to be arranged far apart enough to create brand new types of 3D structures. And those 3D structures can be tetrahedral, trigonal planar, et cetera, right? For carbon, we're definitely going to be seeing linear, tetrahedral, and trigonal planar, which is more flat. So when you actually use the separate theory, it helped us get 3D geometry. You can see here, let me go ahead and erase that. You can see here that carbon actually creates 109.5 degree angles between any of the four bonds it's making. So when you're looking here, you can say 109.5 degrees, 109.5 degrees, 109.5 degrees, and 109.5 degrees, right? Okay. So as you can see, because of that theory, it helps us understand the arrangement of these electron groups. And then, of course, that helps us understand bond angle. We get the geometry there. So now we're saying, yes, we have these empty orbitals here, and this is where the potential bonds can happen. Sure. And then, of course, tetrahedral is the geometry. Tetrahedral is the geometry. That is so strange. Write that. Right. Tetrahedral is going to be the molecular geometry and the electron geometry for this molecule of CH4. We'll actually talk about this simple alkane as we go along. You also can say tetrahedron. That's another name that we hear for tetrahedral as well. Okay? So what happens is we often layer theories to answer questions about atoms and molecules anytime that we need in chemistry. Okay, so the goal is that we're going to be using the separate theory, we're going to be using valence bond theory, which is going to come up next, and that's going to help us start making connections of why do these carbon atoms make such stable bonds, right, between a lot of different atoms and of course with itself. All right, so folks, you might see this a lot, which is going to be called a flashcard moment. Flashcard moment. Oh, sorry. Now, flashcard moment, it just means that you need to take the time to write down some details about carbon. This is our first kind of introduction to it. I just want to make sure that you are stopping yourself and getting active in the lecture. Take your time, write down something about what carbon is. For example, the front can say, why carbon? The back can be an answer in your own words. Of course, this is not the end of all the conversation, so you want to leave some space for details that you want to add as well. For me, if I was writing a flashcard right here, I would say carbon, ability to make four bonds, tetrahedral, things like that. I might even write the electron configuration just if I wanted to remember how to do it. All right, folks, see you in the next video.